I want to build a colour name badge display based on the Raspberry Pi Pico. Instead of using a specific Pico modules, I'm using the generic MSP2401, a 2.4-inch display. I previously showed code to drive this display, but the display was on a breadboard, and you can't wear a breadboard, so I need to move it to a PCB just like this one. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, robotics, IoT and other fun tech. Please remember to hit that subscribe button and join the community. I'm not an expert on PCB design. I only got into this part of making 4 years ago, and I design a PCB every few months. I collaborate with a few experts in the field such as Jordan Broom, who I had on the channel as a guest last year. I also lean on the support of my partner, PCB Way, who fabricated the board for this project. I've talked previously about all the checks they do as part of the design and production of the board within their fabrication service. PCB Way are also the sponsor for this video. In this video, I'm going to go through my design of the PCB and the considerations in doing so, plus the assembly of the finished display. If you like the video and it helps your learning or projects, why not buy me a virtual coffee or lunch or a holiday? Use the super thanks button below the video. Please do hit the like button on the video too, and subscribe for more. I do appreciate it. So the concept here is to move from what we had last time when we were just controlling this display and I was showing you all of the code, so a world where it was all sitting on a breadboard, to a world where it is actually on a nice PCB that I can actually use as a name badge. Now, it does look a slightly odd design as a name badge because I'm actually exposing everything and showing all of the electronics that there is, and all of the board actually open. There's no enclosure, there's no glass. It is actually all shown, and that's because I want this as a conversational piece to open conversations about what we do on our channel, rather than actually trying to hide it and say, here is a really lovely display board. PCB Way are not just the sponsor for this video, they partnered with me in the project fabrication. I was able to order the PCB right on their website, specifying its dimensions, the number of layers that I wanted, and the black finish. I then uploaded the Gerbil files from KiCad. That's always the slightly tricky bit. The experts at PCB Way then checked that I'd given them all the files and that the board could be fabricated successfully before confirming the cost. Once this was paid, fabrication could begin, keeping me informed right through the process. In about a little over a week, my PCB had arrived and I was delighted to get started on building the project. Thank you, PCB Way, for a fabulous partnership. I normally start my designs with connections and how actually the components are going to connect together, but this time I really had to work from physical and to say, right, we've got the display, now let's put a Pico next to it. Where do I want that to be visible? Now that leaves me with a nice little space in the top right corner there. What can I put there? I know, I could put a TPM there. And of course, finally, I think I'd like an LED to be able to tell me what's going on. I'm going to share all of the design from KiCad on the GitHub repo that I was shared last time. And the connectors I'm going to use primarily to drive this display, they're going to be the same connectors we used when it was on the breadboard. The reason I'm using those connectors, well, actually they happen to all be largely on one side of the Pico, which I thought would make it nice and easy to connect from there down onto the display as we actually physicalize this onto a PCB. So all of these connectors are actually SPI, and we're going to use both the SPI one like I did last time to drive the display, but actually there is a second SPI option with this TFT display to actually connect to an SD card, and I'm going to use SPI 0 also from that same side of the Pico to actually drive that. Then I'm going to use the additional connections I've got on the other side of the Pico to give me things like a UART. I want to have standard I/O, and actually I want that both on pins on GP0 and 1 and GP16 and 17, which is where I normally pull them off of. So I'll connect those up as well. And if we could, it would be nice to have some additional capacity available so that we could have I2C 0 and 1, possibly for some extensions in the future. So I might want to just pull those off the board too. So I've put the schema into KiCad, which is where I'm going to design my PCB board. The first thing I guess I was placing in here was the Raspberry Pi Pico itself, and then the connectors for our TFT display. And there are two connectors on the back of that display. There is that 14 pin that's got the main connector for the SPI interface to the display, and then a second SPI interface which is on a 4 connector block, which is to drive the SD card reader. So to help me out, what I actually did here is I actually changed the pin assignments and actually put pin names, there we go, that's a bit better, pin names actually into the standard header pin component, so that I actually knew what was on which channel, because it made it a little bit clearer to display as I'm trying to draw things out and connect them up. And I've done the same thing for the second connector for our TFT display, which is only 4 pins there. So for the main one, I'm just connecting that all straight into the various pins that I chose to use and consistent pins that I was using from my breadboard for all of those services. So that is on SPI1 on the Pico and all connected over here. Now for this for the SD card, I suddenly realized that, well, actually this is going to be kind of complicated, because I want to actually share that, because that's on SPI 0, and I want to share that between the TPM and the SD card. So they're going to have different chip selects, of course, but in terms of the clock, MISO, MOSI, those are going to be consistent and common. So the easiest way I found to do that, and a way I haven't previously used, I must admit, in KiCad, because I'm not the greatest expert yet at designing PCBs, to define them as their own net. So I've got net definitions here for the clock, for MISO and MOSI. And that way I can share those here on the connector out to my TFT display, here on the pins that I'm using actually on my Pico to drive them, and over here, which is the connectors out to my TPM. The other thing I wanted is to make sure that I had UART 0 available to me on some external connections, so that I'm able to drive standard I/O and see what's going on, mainly from a debug point of view, so I can run telemetry across there if I need it. So I've actually put 2 connectors for that. So I've got one up here, which is on my normal pins 16 and 17, or GP 16 and 17, which is where I tend to run my standard I/O over UART. But I've also put it on 0 and 1 and given myself those 2 as another option to choose from. So that left me with a bank of GPIOs that I wasn't using at all, and I thought, well, hey, they're available, I could do something with them. And that's the 18 to 21 here. Now, usefully, 18 to 21 has I2C on it, and it's got both I2C 0 and I2C 1 ports on the Pico. So, hey, that was useful. So I've actually pulled those off and put them into a 6-pin connector with 3.3 volts on top and ground on the bottom, and those pins in between. Don't know whether I'm going to use it, but as I'm designing the board, I thought it was worth actually having it available to me. The final bit I've got on here is an LED, because I felt I had to have some components actually on here that's anything other than the module, and it's always useful to have an LED and to be able to see the status of the board. So I've put an LED on there as well. For the actual PCB layout, the real place I was starting with is actually the position of the components and the shape of the board. Particularly with the connectors for that TFT display, it's crucial that obviously they are in exactly the right place from the back of that display, and indeed those bolt holes are in exactly the right place, and we can then work that things out from there. We've got the LED, and I decided to put that just up in the top right corner here. I decided to use a 1.8mm LED because they're nice and tiny. They sit nicely on a 2.4mm separation between holes, so they're quite nice. So that's what I've used for the LED on here. And then down here next to my connector for my TFT display is the connectors that I've got for my UART 0. There, the one's going into 16 and one's going into 0 and 1. And then the block there for the two I2C connectors if I want to use them. All of the previous boards I've designed have actually been 2-layer. But when I looked at this and looked at trying to do the routing on this, I realized that actually trying to do this on 2 layers, which I think would be possible, but it's going to end up with a huge number of vias as I try and skip over connections and things. So I thought I would be really advanced and use PCBWay's great production service and produce a 4-layer board. So this is all running on 4 layers. Now, when you use 4 layers, people who know what they're talking about tell me that there is a methodology you can apply to your 4 layers where you're using the top and bottom layer as ground and power, and then grids, and then the in-between layers to provide you for a for laterals on one layer and longitudinal connections on another. I've ignored all of that and just gone freehand of how I wanted the connectors to work, which may or may not be a good idea. It is enough to make the board work, and the board works perfectly, and that's at the end of the day I think what's important. So I'm not necessarily advising this is how you should do it. I think there may be better ways of laying things out, but yeah, that's how I've done it and why I went with this 4-layer, just to make my life a little bit easier with routing. This is the final PCB fabricated by PCBWay. It's a 4-layer board of 1.6mm thickness with, of course, copper layers, and it's got a surface finish of HASL lead-free. You can see I went for black as a good background. The PCB for the display is going to be red, and the PCB for a Raspberry Pi Pico is of course green, so I didn't really want another colour in there. I've also used minimal silk screening on this board because I didn't really want it to distract from the actual display itself. Right, let's get this board assembled, starting with of course the Pico, and let's get some header pins on there and then the Pico, and we can get that soldered in place. The lovely thing about having a board fabricated from people like PCBWay is that it's really easy to actually solder it together, much easier than working on prototype boards and trying to connect this up on them. Right, let's get the LED in and the resistor on as well and get those soldered in place. I'm going to get some connectors in place for this display module so that we can actually get that secured onto next. These I always find quite fiddly actually getting these connectors in, especially as I didn't have a 14-pin connector. So I'm actually having to force 2 connectors to be side by side exactly, which worked okay, but did make me worry a bit when I was putting this through together. Then we've got some additional connectors that might be for my I2C channels or for my UART, depending on what I want to do with these. But they're there and nice and black, so they don't really stand out against the board, but just provide me with a little debug and a little bit of additional expansion if I need it. So here we've got the board fully soldered up, and that's not too bad for me. I'm not the greatest solderer in the world, but that seems to be good. And then with the display and the Pico and everything actually nicely fitted. The finalized badge looks like this. I'm actually powering it via a LiPo battery, and I've put a LiPo controller shim on the back of my Pico, which you can just see there underneath the Pico, because it's actually got a little power button there to turn on and off the LiPo battery. The battery itself actually is sitting and stuck to the board just underneath my display, and you can just see it in there. On the back of the unit I've got two magnets to actually use it for attachment purposes, and they're encased in a little bit of 3D printed plastic. Here you can see the display operating and looks pretty good. It's running basically a demo program which is basically just displaying PNG images that it's taking off of that SD card plugged into the bottom. I'll share how this code actually works in a later video. Did you notice I've left off the TPM? That part's really a work in progress. It's the top end of advanced stuff, I think, for this channel, but worth an episode in its own right. But what do you think? Do you want to see an episode on the TPM and the security involved? Leave me a message in the comments. I'm really pleased with the outcome of the project. PCBWay did an amazing job with the PCB. It looks good. With their help, I got this nailed first time too. This is the first board I've used the LiPo shim on. I'm really impressed with this little module. I can do a review on that as an episode too if you'd like. Let me know. Using it with a 700 mAh battery, I'm getting about 5 hours of usage. I think that's quite impressive considering the small size of the battery and the fact I'm actually being quite aggressive with the data throughput, pulling data from this SD card to the display all the time. There's no power saving techniques at all. If this video or any of my videos helped you out, why not buy me a virtual cup of coffee to say thank you. There's now that super thanks feature live on my channel just below the video. Just click the button. Thank you very much for watching. If you enjoyed the video, please do hit that like button and please subscribe to my channel so you don't miss the next video. Bye bye for now.